Hello, my name is Paul Sotherland. My project is time series data live stream simulation using Google Cloud BigTable. For this longer form presentation, I'm going to first go through a slide deck to give some background on what BigTable is and how I used it for my project. Afterwards, I'll do a short demo of my application, actually two applications, and kind of explain what it's doing. So first, generally, um, purpose of this project, I used to work in manufacturing, and a very common use case for data is that we would have a measurement that was populating a database live, and multiple clients or users would want access to this data concurrently. So they might be equipment operators or analysts, but they all had a stake in what the data said, and so the availability of that data was important. Um, so I have two programs. One is basically simulating that measurement, feeding data from a CSV file into Google Cloud BigTable. The second program, which multiple instances can run at the same time, is reading and graphing time series plots based on the most current data in the BigTable at a specified refresh interval that's an argument or option to the program. BigTable is a backend of many Google products that we use. It's designed to be extremely scalable. It's a distributed system, maybe spread across thousands of servers and accumulate petabytes of data. And it's designed really to be still fast under those demanding circumstances. Um, it is a NoSQL database. In terms of describing it as pros and cons, bear in mind that I'm generally going to be comparing it to SQL solutions. Um, One of the original use cases of BigTable is that it was storing data about the web. This is considered sparse data, and by sparse I mean data that doesn't lend itself well to a schema. If you were to schema it in SQL, you would have a lot of empty fields or tuples. As I've said before, it's very fast and scalable. It may not be the best solution for ACID guarantees. That is, your bank may not want to use it to back up your transactions, and those transactions be correctly represented all the time, everywhere. It does have a query language of its own that's sort of based on SQL, but it's not as rich. There's not the notion of a join, for example. In fact, typically a BigTable database does not have multiple tables. It's really a large table. Depending on your use case, you may or may not like this. It is a software as a service. And so the way to pay for it is on a rolling basis. And it is only available for Google because they made it and they own it. Kind of already indicated this, but BigTable's uh, designed to handle data from the web, among other things. It is somewhat, you can think of it as a multi-dimensional map or dictionary. Each row, each column family, each column has its own key, and so you obtain a value with a combination of those keys. You can also use, and I'm not doing this for my project, but it's available, you can use BigTable to store multiple versions of the same data. So if you wanted to watch as a web page evolves and is updated and wanted to see changes in that, that is a use case that BigTable is good at doing. Because everything is keyed, including the rows, BigTable is well suited to time series data that I'm using for my project. Each row has its own key, and so I can use that as a time stamp. That is, the key for each row can be a timestamp, and a value can be a measurement, for example. My project is in Python. I'm using BigTable's Python API, as well as matplotlib pyplot to produce visualizations of the data. How do you get BigTable? Well, if you're a student like me, you can get a free $300 credit to use. This will be eaten up quickly because BigTable instances are expensive. Once you have your instance set up, you need to authenticate into it with your program. There are a number of ways to do this. Since this is a course project and others need access to my instance, a convenient way to do this is to obtain keys with specific user roles, that is, say, a BigTable reader or editor, and provide those with the program. That's not something I would do in a production environment, but again, this is a course, it's for learning, and that is an easy way to give you all access to the BigTable. Connecting to it through Python, we have in Google Cloud a project ID, and a given project ID may contain multiple BigTable instances, and so we start by obtaining that instance that we want. And then if we wanted to create a table programmatically, it's fairly simple. We reference our instance, create a table with a given name, and likewise a table needs at least one column family. This is a column-oriented database, and column family is sort of the largest unit in that. I have two programs. The first, which handles the editing that I've just described, as well as the generation of new data in rows, is Data Builder. This is refreshing a table and writing data on a rolling basis from an external CSV file. The second program, multiple instances of which can run at the same time, is Data Reader. This is responsible for obtaining the data, whatever is most current in the BigTable, at a configurable refresh interval, and producing a time series plot that the user can view and study. So generally a command line overview of what Data Builder does. Deletes the table, regenerates it, and starts writing rows about 10 per second. Likewise, at a high level, Data Reader is going to be generating a plot and refreshing it as the most current data comes in. So if nothing is writing to the database, the plot will stay the same. If we have a Data Builder writing in the background, we will develop a richer and more dense plot over time, and we'll see that in a moment. Some references I used: there's a white paper on BigTable that Google makes available, as well as some very good API documentation. I obtained my data from Data Market. It's a nice CSV file that is well structured for my use case. So now on to a demo of the program. So first, just a quick look at the data. In this case, really it was more interested in the format of the data than the content. I really just wanted data points at some regular intervals to simulate a measurement. In theory, you could, without much adjustment, do this with any data structured this way. That is, the first value, in my case a row key, needs to be a timestamp of some sort, and the second this is a floating point number representing temperature. That's a daily temperature in Melbourne, Australia, over a number of years. So now, first I'll kick off Data Builder, and I've got my project ID and instance ID as arguments to that. So you can see it's refreshing a table, and now it's writing some things. I'll kick off a Data Reader. And this is by default going to run every 5 seconds, refreshing the time series plot. I'll show you some of the other arguments that it has. just so you can see. So you can see you can provide an external JSON file for authentication to replace my own if you wanted to connect to your own instance, and that's also true for the data builder application. Likewise, we can configure for how long the reader runs in terms of number of refreshes for the chart, as well as the interval for the refresh rate. So we're defaulting at the longest refresh in this use case, and I'm going to make this second client a little bit faster, refreshing every second instead of 5 seconds. So you can see they're drawing from the same data source. Multiple clients or users can have quick access to this data, and there's a trade-off that you choose between, how computationally expensive you want to be versus how immediately you need this data to be refreshed. So here we're saying every 5 seconds and fine. Here we're saying no, we need that data faster to know what's going on immediately. And that is my project. Thank you for listening. I appreciate your time.